Hello, boys and girls. Welcome back to the drive-thru. Hungry? Stop by the deli and have a kosher Chinese food sandwich. Alright, we're on Chapter 5, and we're going to start with Always, Sometimes, Never, question number 1. A rhombus is a rectangle. This answer is sometimes because a rhombus is a rectangle sometimes if a rhombus is a square. So if this is the rhombus, that doesn't really look like a rhombus. One retry. Okay. If this is a rhombus and it's also a square is also a rectangle sometimes, so that's why the answer is sometimes. Number 2, a square is a rhombus. So if we have our chart, this is parallelogram, and parallelogram had two kids, which is rhombus and a rectangle, and then they had square. So a square is a rhombus always, because when you go up, it's always.
What's the definition of rhombus? You remember? A rhombus is a
square. No. The definition of a rhombus is a parallelogram with all equal sides, and since a square is a parallelogram with all equal sides, it is considered a rhombus. Next, we have a parallelogram is a rectangle. So this answer is sometimes, because a parallelogram is sometimes a rectangle, but it can also sometimes be a rhombus. Next, we have if the diagonals of a shape bisect each other, then it is a square. This one is sometimes, because if in a parallelogram the diagonals always bisect each other, so it could sometimes be a square, but it could also sometimes be a rectangle or a rhombus. And then next we have number 5. If the opposite angles of a shape are congruent, then it is an isosceles trapezoid. So if we draw an isosceles trapezoid, we look at the opposite angles, and these are definitely not congruent, so this is never, because these two angles are congruent, and these two angles are congruent, but these angles are not congruent, so this one is never.
Why don't you go ahead and mark that isosceles trapezoid with how the angles actually are. There you go. Are you ready?
Yes.
Next page.
Okay. What is the most descriptive term for a quadrilateral whose consecutive sides are 5, 6, 6, 7? This one could possibly be an isosceles trapezoid. If this were 7, this were 5, this is 6, and this is 6. However, we don't know for sure that it's an isosceles trapezoid because it could be a different shape, and we don't know for sure. So that's why it's a quadrilateral, which is the most overall term. Number 2, what is the most descriptive term for the quadrilateral with vertices 0, -6, -4, -2, 4, 6, and 8, -2? So if we draw a coordinate plane, and we mark out the points, so 0, -6, then we have -4, 2, then 4, 6, and 8, -2. So if we connect these points, we can see that it's a quadrilateral, but in order to find the most descriptive term, we have to figure out whether the angles are right angles, so we have to figure out whether they're perpendicular by finding the slope. So if we find the slope of these two, 6 minus -2, which is plus, 6 plus 2, and then 4 minus 8. So we have 8 over -4, which simplifies to -2. Then if we do this one, we do this one. So -2 minus -6 over 8 minus 0. So that's -2 plus 6, which is 4, over 8, which is 1/2. So we can see that these two are perpendicular because they have opposite reciprocal slopes. And then if we do these ones, we have 6 minus 2, then 4 minus -4. So this gives us 4/8, which is 1/2. And then we take 2 minus -6, -4 minus 0, which is 8/4, which equals -2. So we know that all the angles are right angles because all the sides are parallel. Now we have to figure out whether it's a rectangle or a square. So we can do this by finding the slope of the diagonals and seeing if they're perpendicular, because if it's a square, then the diagonals would be perpendicular bisectors of each other. So we take 6. I'll do this in a different color.
Draw that diagonal red. Perfect.
So we're going to take 6 minus -6 over 4 minus, oh, we're loading.
You're going fine. You didn't do anything wrong.
4 minus 0, which is 12/4, which simplifies to 3/1.
I'll change your color one more time.
And then for this diagonal, we're going to do blue. So we have 2 minus -2 over -4 minus 8. So that gives us 4/12, -12, which is 1/3. So since this one is 1/3, and this one is 3/1, these are opposite reciprocals of each other, so they are perpendicular bisects of each other, so this one is a square.
You guys are doing great. We got one more.
Okay, so if 2 of the 5 labeled points are chosen at random, what is the probability that they are supplementary? So, we would list out all the angles that could be picked out in pairs of 2. So we have 1, 2, 1, 3, 1, 4, 1, 5. Then we have 2, 3, 2, 4, 2, 5. Then 3, 4, 3, 5. And then 4, 5. So now we're going to look at the angles and see whether they're supplementary or not. So 1 and 2, we can see that those are supplementary, so we'll circle that. 1 and 3 are not supplementary because they're vertical angles. 1 and 4, these two are supplementary because 4 is equal to 2 because of the parallel lines, and corresponding angles are congruent, and those two are supplementary. And 1 is supplementary to 5 because 5 is equal to 4, which is equal to 2. Now 2 and 3, these two are supplementary, so we'll circle this. 2 and 4 are not supplementary because they're congruent. 2 and 5 are not supplementary because they're vertical angles. Now 3 and 4 are supplementary because they're on the same side of the parallel lines. 3 and 5 are supplementary because 5 is equal to 4, and 4 and 3 are supplementary. And 4 and 5 are not supplementary because they're vertical angles. So if we count up the total number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 1, 2, 3, 4, 5, 6 possible choices. So if we simplify that, we get 3 out of 5. So that is the probability that the angles are supplementary if 2 are picked at random. Boom!
Can you give her a